Hi, everybody. I'm Alison. I'm one of the 6 to 10 physics professors here at Reed. Generally, we have 6 to 7 of us teaching in any given year. And my main research subfield is astrophysics. And even more specifically than that, I study questions surrounding how stars form in galaxies outside of our own. You would call what I do observational astronomy, and kind of connecting what we see to the theories that we have. One of the things that I think really sets us up to be different here at Reed is, we really have a distinct mission that we're trying to teach you within the first 3 years of your time here in physics. We're really trying to teach you like kind of the core of undergraduate physics in those 3 years as opposed to 4, because in your 4th year, you're going to do your year-long senior thesis, which is sort of a researchy extended project. And we want to give you enough physics background within 3 years that you can launch yourself into a fun project that you really love, doing physics that you're really interested in. So we've got like the core courses. So this is what I was talking about. So each row is a year, and we've got fall semester and spring semester. And so these are like physics courses that you do in the first, second, and third year, leading up to the thesis year. And that's not, it looks like it's almost nothing right now. There are like the math courses too. So in italics, in the first 2 years, there are also math courses that are involved that are required for the physics major. Here's just my little slide. We do have lots of majors. If you compare us to other liberal arts schools, we're very close to the top. Carleton, I guess, beats us by like 1 student over 2 decades. So with lots of physics majors, that also means that we can offer a lot of electives. And so I think this is something that's more distinct at Reed is the number of upper level electives we have, particularly because we leave that 4th year fairly free for you to take these courses. So we have a general relativity course. That's pretty uncommon for undergraduate only institutions. Thermal physics we offer every single year because it's a pretty core thing. If folks are interested in going to grad school in physics, it's absolutely something that one should take. There's advanced quantum, advanced electrodynamics, and then scientific computation, which is becoming more and more of an important skill in almost all subfields of physics. So we're starting to offer that every year now. And then we have a few every other year electives, which you will get a chance to take. You might take them your junior year, or you might take them your senior year. So astrophysics, elementary particles, optics, solid state physics, all fit in that boat. These fit, sort of particularly the upper level electives, fit the research interests of our faculty. So we sort of, we're not a huge department, but we cover the different subfields of physics pretty well. And then the last thing I wanted to show you, one of the things that makes Reed really special and I really love is some of the senior thesis projects that folks have done recently. All of the things on here are super cool. There's like a mixed biophysics thesis, cells on gels, tons of different stuff, some pure theory. And this is really, I think the sort of why our physics program is organized the way it is with the sort of core stuff in the first 3 years is so that you all get to do fun things in your senior year for thesis. A few things just that we also do as a department. We have weekly physics seminars every single Wednesday throughout the term, and they're super well attended. So even from your very first year, check out the physics seminar topics. If it sounds interesting, come. If it's your very first year, you might not understand the whole entire talk, but you'll get something out of it, and your eyes will be open to a new subfield of physics. And so it's even worthwhile, even if you get lost a little like halfway through the talk. That's fine, doesn't matter. What else do we use? So I host a weekly journal club called Astrobites, where we talk about astrophysics papers. So that's particular for my subfield, but everyone is welcome to it. We also have a telescope on the roof of the building, which we couldn't use with COVID because you can't be in the dome and 6 feet away from people. But hopefully next year we're back up to using the telescope, and training. The training is open to everyone, actually not physics major required, but there's training to use the telescope in the fall. And then once you're trained, you're allowed to use it as long as there's sort of 2 students involved in using it just for safety at night. There's the Reed Research Reactor, which likely you have heard about, but is a undergraduate run nuclear reactor that different projects, students propose to do projects and can do projects on it. And then within the department, we have like a sophomore, at least until COVID, we had a sophomore bowling event. We'll see where we're at next fall, if we can start that up again, or if all the bowling alleys have gone defunct or something, we'll have to make up some new event. And then every spring, we have a department softball team that trains, hangs out, and like throws a ball and tries to hit it. Sometimes no athletic skill required, mostly hanging out, but we play softball sort of weekly leading up to the big Ren Fair softball tournament. We have the Fab Lab in the basement, which can help you basically make things for project. If you have your own independent project that you want to do, there is a wonderful, wonderful person named Jay who runs the Fab Lab and can help you use a laser cutter, can help you use various woodworking machines, can help you make things. Just this year, even in the year of COVID, the students started up a chapter of the Society for Physics Students, which is like a national organization, but now for the very first time, we have a Reed chapter. So this year they were very limited in the events they could hold. Their goal is to really kind of create even more community across the years of the physics majors, because yes, we have 20 odd people in a given year, but there isn't always, like the first years might not have too many reasons to run into the seniors, but this is a structure where they would have more social events to be able to do that.
Are the intro series classes at Reed one large lecture with 80, 100 students, or are they smaller sections?
So there's one huge lecture, 80 to 100 students, 3 times a week for 50 minutes. And then outside of that, we'll have a small group conference for 80 minutes a week that is run by a professor. And that's about 10 to 14 students, and usually geared towards really working on problems together, sort of in small groups. So more focused on problem solving sessions. And then you have lab, which is also sort of much smaller, sort of 10 people per room in 2 different rooms at a time.
How does Reed support internships for physics majors? What sorts of research and also internship opportunities are there for specifically physics students at Reed?
Totally. I'd say that it comes down to sort of 3 type things are researchy internship, like fit in that broad category. So one is doing summer research here at Reed with a Reed professor. So every summer we have, I don't know, between 8 and 12 maybe students here working on research with us. I'd say the experimentalists generally might have 2 or 3 students. The theory folks might have 1 or 2. They tend to have a few fewer. So that is one way of doing research here before your senior year, right? Because senior thesis is going to be there for everyone to do at that point. So I'm more focused on what's before that. So summer research here, and then summer research elsewhere. We are very happy and write lots of recommendation letters for Reedies to do research elsewhere over summers. And that's great because, right, there are facilities that we just don't have here to do physics research. So we don't have a gigantic physics accelerator, but we've sent students over to CERN, right? And they can go to Switzerland or France and do research at CERN. And we send students to various big labs here in the US as well, Fermilab and just all over. And then there's also the option, particularly in your junior and senior years, of doing an independent study, right? And so that's different than thesis. It might be, and they can be different flavors. They can be really sort of with a professor's research. That would be one flavor for independent study. And there's also independent studies that's, hey, there are a lot of physics electives at Reed, but you all don't cover physical oceanography, and I really want to learn about it. And so if you can find a professor, and generally we're pretty open to this, that is willing to sort of do a reading type independent study with you, you can tackle like some subfield of physics that you're really interested in that isn't in the course offerings here at Reed. And I guess that type of independent study might not really be a research internship, but the other type of sort of doing an independent study in the line of some faculty's research would be more in that vein.
Do you see Reed as having a stress culture, and how do you think that physics students balance their work demands with personal well-being, mental health, and non-academic activities?
Each 1 credit course should be taking 8 to 10 hours of your time outside of the course. So physics courses and the lab sciences in general do take a little bit more time because we also have 3 to 4 hours of lab, right? And so that's not outside of class time, that's actual class time. So I think things are doable. It's not necessarily easy, but if you come in and stay organized about time management and keep getting enough sleep, it is not that it has to be 100 hours of your time to learn the physics that we want to teach you. I do think it's a manageable amount, and you really should, if it becomes ballooning outside of that, like 8 to 10 hours, then do go after and talk to your professors, because we do not want it to be taking that long. We know it shouldn't be.
Could you tell us a little bit about, and specifically about the math physics interdisciplinary major? Could you tell us a little bit about how those programs overlap, how they work? And would they hypothetically free up, if you did math physics, if those requirements overlap, would that free up time to do more physics electives?
Double majoring at Reed is very rare because it requires you to do 2 different theses. And so every year it's like 1 to 3 students. I've been on the thesis orals of 1 student who was a math philosophy double major. And so in her senior year, she wrote 2 different theses, 1 in math and 1 in philosophy. And it just ends up being by the time that people get to their senior year that they would rather put all their effort in 1 thesis as opposed to 2. Most people, right? The vast majority. It really does not mean you can't take all of the courses you want to take in some other field, right? So that's not, right, double majoring other places without a thesis requirement, that's what a double major means, is you're taking a lot of courses in X and a lot of courses in Y. Here, you can take a lot of courses in X and a lot of courses in Y, but unless you really want to write a thesis in both, you will not be a double major. So that's what the double major is here and why it's fairly rare. Minors have become a thing, but not all departments have them. So it's mostly the languages and a few other departments in the humanities. None of the STEM departments yet have a minor. And I don't think we're on the brink of it. But that doesn't mean that you can't, like a lot of physics majors take a bunch of math courses, like beyond the required ones. The math physics interdisciplinary major, we actually formally just ended the standing major. And the reason we did that is because we found it wasn't serving people super well because they were skipping the junior lab course. And for someone who is more theory oriented, that might be the very last opportunity they have to do lab, right? They might go on to grad school and do no lab whatsoever. And it was this junior lab course that's able to give people a clue about what research in a lab is all about. And so we found people weren't being really well served. Sure, a theorist might not need to use those lab skills, but if they don't even know sort of what lab is all about, then they're actually a weaker theorist by not having that experimental background. For any student whose interest is fiercely in the intersection of math and physics, one may propose their own independent math physics interdisciplinary major that is really tuned to your exact interests in the overlap of math and physics. And so that is totally a possibility. One does that their sophomore spring when major declarations are required. And all you have to do is talk to the physics department, talk to the math department, get the departments on board with your proposed plan of study thereafter that melds the fields in the way you're interested, and it's totally possible. And I do not expect math and physics to not approve such things. Professors doing research in theory, like advanced theory, like GR and quantum fields and condensed matter, do undergrads really get enough experience to participate in this research? And I would say, yes, it's in a guided fashion, right? But our professors know we know exactly where we've taken the students up to in that senior year where they're going to launch in their senior thesis, and so can help the student craft questions that work, right? That aren't sort of totally intractable, but do touch on these fields of GR, quantum, and quantum field theory in their senior year.